Very good evening to everyone present here. Thank you everyone who have joined today evening, and we'll be starting the program in a couple of minutes. அனைவருக்கும் இனிய மாலை வணக்கம். Very good evening to everyone present here. Before we start the program, may I now request Honorable Director of IIT Madras and Mr. T.R. Shashwat, CEO of MindGrove, Mr. Sharan Srinivas, CTO of MindGrove, Mr. Mauna Krishna, Mr. Kapil Shyam, Mr. Santosh Pavan, Ms. Swati, and Mr. Rohit Srinivas to take up the seats in the stage. Thank you. May I now request everyone to rise up for the Invocation anthem. Tamil Thai Vazhathu, followed by Vande Matram.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ்பரத கண்டமிதில் தெக்கணமும் மதி சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரிதனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியழ்ந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே. वन्दे मातरम् वन्दे मातरम् सुजलां सुफलां मलयज शीतलां सस्यश्यामलां मातरम् वन्दे मातरम् शुभ्रज्योत्स्नां पुलकितयामिनीं फुल्लकुसुमितद्रुमदलशोभिनीं सुहासिनीं सुमधुरभाषिणीं सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम्.
Thank you. I take this opportunity to welcome you all to the first event of Triumph Talk under IITM Startup 100 Mission. May I now request Professor Kamakoti, the Director of IIT Madras, to welcome the gathering and share a few words on why IITM Startup 100 Mission. Over to you, sir.
Thank you very much. Friends, a very, very hearty welcome to this most important milestone achievement of IIT Madras as an institute and also our budding startup MindGrove. I request all of you to please join me with a good round of applause for the very big achievement. Friends, I would like to talk about two important things today. Each I'll spend around 2.5 minutes in the 5 minutes allotted to me. The first 2.5 minutes, I'd like to talk about Startup 100 mission of IIT Madras. This year we have set many targets in the last financial year. We opened the first campus abroad of any other IIT at Zanzibar. We were the first to introduce sports quota. And we had a very ambitious team of having a patented day scheme. And we did have the patented day scheme. We set a target of 366 patents, and I'm very happy to inform you that we have finally concluded with 378 patents filed, almost more than a patent a day. We had the first ever admission of a medical sciences and engineering bachelor's program. Again, one of its very unique in the world. We have started the Department of Data Science. So many, many firsts we have done. And the next goal, next goal is that we are now looking at every third day, we want a startup to be born in IIT Madras. And that is our big ambition. When we are thinking about, when we are running at 25 to 30 patents a year, 366 patents actually seem to be a very big. Patent a day was a very big mountain in front of us. Now we have just crossed it with such an ease that the patent team is very upbeat to say that we can do 2 patents a day. So the Startup 100 is not just a dream, but I'm sure within a few years we will touch that reality. Now what it means to have this Startup 100, we need students, the undergraduate, the postgraduate and the research scholars to get motivated and have confidence in being an entrepreneur. Friends, today in the morning, we just announced that this year, again for the first time in the history of IIT Madras, the total amount of donation and CSR funding we have received is 583 crores. We have crossed 500 crores this year, in which 389 crores came from our alumni. And all of them were entrepreneurs. 15 years down the line, the then director when he wants funding, when he or she wants funding, we'll be looking at 5,000 crores. Who is going to give that? The entrepreneurs of today. And that is what, yeah, I see some hands going up. Thank you very much. We need to have that scale of startup companies to come up, not just to fund IIT Madras, but to take our country to a Viksit Bharat 2047. We will become superpower only when we become employers. And if IIT Madras students cannot become employers, who else can become employers? And that is the full belief that as a director I have on all of you young students, that we will all make it happen. And we would like to reach this 100 startups, deep core startups, not just some grazing the grass at a ground level, but very, very deep core startups. And we are committed to this. Now, what is the most important enabling fact for this? We have this great building donated by Shankar and Sudha. We have C5 here, we have Nirman here, we have the E-Cell, and we have Gopalakrishnan Deshpande Center. We have so many things that are encouraging this. We have a very vibrant industrial consultancy sponsored research cell where the patents, almost we have become a patent factory there. All these are happening. Now the most enabling point is that all of you must have the trust that you can be an entrepreneur and you can succeed being an entrepreneur. That trust should come to you, to your parents and everyone. And with that interest, we have organized this. We will be organizing a series of talks. These talks will be, one, celebrating success, not celebrating some small success, celebrating big success. So we'll have a series, I'm sure this year, to my mind, I know that we will have at least 4 grand success. One starts today. We will have lectures which will basically talk about entrepreneurship, talk about what to do, what not to do. We'll get some of the world leaders to come and present at C5, the same place. We will have monthly one event which will basically guide you, give you the trust, give you the confidence that you can be a successful entrepreneur. I think that is the only point that I need to touch so that we realize this entire mission, Startup 100 IIT Madras. So we will all work on this, and I'm sure this will be a grand success. I have no doubt about it. I have no doubt about the capabilities of our great students here. To start with, friends, 2013 IIT Madras, with a group of people, we decided at the computer science department that we need a processor for the country, specifically from a security angle, also from making ourselves self-sustained. Microprocessors there everywhere. In this room, I can challenge, we could see at least 1,000 microprocessors at this point of time. So this is the rampant use of microprocessors, and India must have a family of microprocessors. So 2013, we joined hands with Berkeley and MIT on what we call as the open source RISC-V microprocessor. That started the Shakti program around 2015. We also got the confidence that this RISC-V microprocessor is the way to go. Around 2017, we managed to convince several committees and get a funding. After that, 3 chips have been taped out from IIT Madras, and all 3 chips have been first-time success, which gave us a lot more confidence to give these chips to the startups, give these designs to the startups, and say, boy, you can all, boy or girl, we can all work and you can make it successful. And with that good intention, we made the whole thing open source, and several startups have come. There are successful startups. We have more than 10 startups using these RISC-V microprocessors, many of them coming from IIT Madras and CDAC Trivandrum. And after that, the point is we had 3 test chips. Now we had to go and give a commercial chip to the world. And that is where MindGrove started. They are going to describe the journey. But I must tell you, this journey was really a sine wave. start at 1 and somewhere -1, 1, -1. And these kids had the temerity, they had the perseverance, they had the courage to go and work with this, went and taped out a chip at a very contemporary technology, 28 nanometer, and today they have a working chip. And this is going to be of a commercial quality. And this is for the Shakti project and for the Digital India RIS-5 project, which is launched by the MeitY. The minister, Sri Rajiv Chandrasekhar, realized that India needs like a national flag, like a national anthem, like a national bird. India also needs a national microprocessor. And RISC-V has been the national ISA, National Instruction Set Architecture. And now we have the first commercial chip, which can go into a lot of applications today. So I will now leave it to the entire team to describe their journey. And very importantly, I want to tell you here that now is the stage where the startup has come. They are not giving a test chip. They are not giving a doll. They are giving you a working silicon. Microprocessor, I've been teaching architecture for 22 years, is one of the most complex digital design a human can conceive. That much I can tell you. And this processor, I hope that the big Indian industries like the Tatas, the Reliance, the Mahindra and Mahindra, the L&Ts, who are all working on automobiles, working on the smart cities and communication related projects, will seriously consider evaluating this chip and make it part of their product line. And so this is the today's context, and I will now leave to all the young team members to come and describe their journey. Thank you very much. Thank you for coming.
Thank you, Professor Kamakoti. We as youngsters will be promising you that like we'll make India as a superpower country in the near future. So, being the first event of this series, we are going to witness the victory of the fabless semiconductor-based startup MindGrove. So, MindGrove Technologies have launched India's first commercial high-performance SoC named Secure IoT. Let us know more about this project, the team, and their success. May I now invite Mr. Sharan Srinivas to take over.
Hello, everybody. I'm Sharan, employee number 2 of MindGrove Technologies, and also a part-time PhD student at IIT Madras under the guidance of our very own Professor Kamakoti. And when we booted this trip, and we'll be going through that in a very short time, Professor called us up, Shashwat and I, and basically said, share your experiences. So, and he wants to demonstrate, as he just mentioned, he wants to demonstrate the power of the scope of entrepreneurship, the power of entrepreneurship, and the sheer capability that we as a society and we as a country have to invent new products, to invent new ways of doing things to satisfy our own needs and to satisfy the world's needs. So from that scope, the vision that Professor just outlined is very, very large. But then giant leaps for mankind begin with very small steps of a very small set of people. And on that note, when he asked us to talk about entrepreneurship and talk about our experiences, we found it a little bit difficult to talk about how, how we go about entrepreneurship and all that, since we ourselves are first timers at it. So we decided that we are going to talk about our journey. We're just going to tell you the story of what we did, what we went through, the technical process a little bit, the emotional parts, some of it, time permitting, and go through, hopefully, give you a broad outline of what it took for us to bring this microprocessor into picture. That is what we call the journey to secure IoT. So a quick introduction, MindGrove is a fabless design company, and we reimagine edge computing. We are venture backed. We raised a seed round of $2.33 million led by Peak 15 partners, Special Invest, with participation from Special Invest and Whiteboard Capital. We are a company that is incubated at the IITM incubation cell, and we are also incubated at IITM Pravartak Technologies Foundation. So Pravartak is a technology innovation hub with a specific focus on cyber physical systems, and they concentrate on SNACs. It's an acronym for sensors, networks, actuators, and control systems. So we are incubated by them. And we receive a lot of our EDA tools from Pravartak, and we'll be telling you how Pravartak and IITM in general have been lending us support in the process of what is going on as we go through the presentation. We called ourselves a fabless design company, and fabless is at the very, very center of the semiconductor supply chain. NVIDIA today is a great example of a fabless company. So is Qualcomm, so is Broadcom, right? So a fabless company is, a fabless semiconductor company, for those who are unaware of that, is a company that designs a chip, but then manufactures it elsewhere typically through a contract manufacturer. So this image that you see on the screen right now tries to explain how MindGrove goes about doing about it. We are the fabless design house, the big green box over there. And we take IP, such as the Digital India RISC-V Shakti microprocessor that was developed at the Rice Lab under the leadership of Professor. We take that and we take other such components, put them together, and we use what is called electronic design automation tools. And ours comes from a company called Synopsys. We take them together and we then design this chip. After designing this chip, we take that design and hand it over to a contract manufacturer, the so-called fabrication plant or foundry. You would have come across that term, hopefully, in the newspapers. There's the government of India is putting a huge effort in bringing in the local ecosystem of fabrication plants. So we hand over this design to the fabrication plant, who will manufacture it. And once the manufacturing process is done, we get what is called a bare silicon die. So the design is literally etched onto silicon as you would draw on a whiteboard with a marker pen or something of that sort. It's a chemical process, I'm grossly simplifying. Once that is done, the chip is taken and put in a particular box, and that box is called a package. So that happens at another place. It's called an OSAT or an ATMP plant where the packaging is done. And once you have packaged the die, the bare silicon, also called a die, you test it. So the silicon is etched, it is put into a box called the package. The die and the package are tested, and then it comes back to us, because this is our way of doing things. It comes back to us. And during this time, we are already interacting with EMS players, original device manufacturers in our ecosystem. And we give them this chip, we give them other support, and we partner with them. And then this chip goes into those products, which are then sold to the market, used by us as end consumers. These can be a great many number of application use cases: consumer appliances, smart locks, motor applications that utilize motors. Smart watches, for example, is another thing that we will look at, right? So before all of that, you need a chip, right? And before you need a chip, you design a chip. And that's what we did. That's what this journey is going to explain. But one thing I want to talk about right now is what happened in our office pretty recently. So what's happening is, if you see in the right bottom, a chip has been loaded onto the board, and they are pressing the power button, and on the top right, you see the boot happening by itself. So we just reset that repeatedly to see the same output again and again and again. This is a very basic boot test. And from that board, that particular chip is currently being removed, put back into the tray. Another sample of that chip is taken up, placed back in, and the test is redone. We power up again, reset again, and look at the output again. So this is a video of the boot process in action. This is a very basic boot. There's more to this boot than that. But this was literally the unedited footage of the first time we started seeing the boot as we expected properly. So I just wanted to show that. And we were testing this with more samples, but for the sake of time, I'm just showing an example. The chip that we just saw being loaded is what is called Secure IoT. That's our first SoC. It's a 700 megahertz SoC with which has a core complex. So this is the Shakti core, and this is the center point. This is where all the computation happens. From there, we have a whole set of peripherals, the green place in the bottom. These are the mechanisms by which communications happen from the core to the components on the outside world. And each of these peripherals follow a different set of rules for its communication. So there's a whole bunch of peripherals that are there. The secure part of Secure IoT is the security complex, where we have hardware acceleration, so cryptographic algorithms accelerated in hardware. A key point to note here is these algorithms were developed, the initial versions were developed at IITM, and we have taken it up, put it on a commercial level, and have successfully taped it out. In addition, there are certain system use cases which are set up for basically administrative work, controlling the system and all of that. So that is, and memory, of course. You need a place to keep your data, so there's obviously memory. So this is a quick introduction of Secure IoT. And I'll leave you with one example of how we are trying to use this Secure IoT. Smartwatches is an example. Last year, 53 million smartwatches were sold in India alone. And we have two kinds of smartwatches. If you look at the left bottom corner, you have your typical entry-level smartwatches, your 1,000 to 2,000 rupees smartwatches. And on the top right corner is your top-end watches like the Apple Watch. We as a consumer have had one generation of watches. We have used it, we have experienced it, and we want more features, we want more experience, we want more premiumness in our watches. We want more value for the money that we are paying. And Secure IoT is designed to cater to these kinds of mid-level applications. It is definitely not in the top end, it is definitely not in the bottom end, but it will entry level, it will definitely help us play to our social needs, because India is a very diverse society, and therefore the needs and the requirements that arise from that society is also diverse. And then the hardware, therefore, that is necessary to satisfy these needs to be pretty versatile. And that's what we've attempted to do. I've been talking a lot, so I think I will sign off from here, because Professor asked us to share our experience. And as he said, designing a microprocessor is an extremely complex thing. No one person can design an entire processor. It takes an entire team, and that team is sitting in front of you today. So what's going to happen is Shashwat is going to play the role of coordinator-in-chief. And one by one, each of my team members would come in and speak about the work that they have done, sharing their experiences, and hopefully giving you a broad walkthrough of how chip gets taped out, and what kind of headaches we find on the way. Because it's nice now that the chip works, but the road to silicon is a very bumpy one, it's a very headachy one, and it's filled with mini heart attacks. So I think I will let Shashwat do the talking there. Thank you, everybody.
Hello, everyone. So I'm Shashwat. I'm CEO of MindGrove, and what I'm going to do now is just introduce the rest of my team. I'm not going to be the one talking too much right now. So to start off with, MindGrove has this philosophy where we say that we come from the application down. So we don't design chips and then try to slot them into an application. We look at the applications and we design chips which can suit all of the applications we're looking for. So what that translates to in a small team is that we believe in cross training, and we believe in everybody in the team working multiple roles, so that if you build something, you should know how your user uses it, and you should know it intimately by being that user. So when one of our designers said that he was a little exhausted by chip design and he wanted to try something else, we said, why don't you go build applications on this chip? And so let me introduce Mauna Krishna, who's our star designer. He was our first designer. He is a product of NIT Trichy, and he is currently doing his masters at IIT Madras also, while working on designing the next crazy microprocessor that we have in mind. So Mauna is going to walk you guys through what applications we have built, which will set the context to why we have built secure IoT in this particular way. So over to you, Mauna.
So thank you, Shashwat, for introducing me like that. So as he said, my name is Mauna Krishna. I was the RTL design engineer. I am RTL design, but I also look into all other stuff also. As we are a startup, we have an opportunity to get involved in a lot of stuff. So I got interested in software development as well. So and then got involved in it. So so secure IoT, that's the name of our chip. If you guys have been following the media a lot since this time, you would have seen a lot of articles about our chip, about our company. So what led to this? What we wanted to achieve was the best performance with less power consumption and added security, hardware level security, as the chip name implies. And once we booted the chip, the level of excitement was really different, really high. It truly did match our expectations. It is fast. You will see some of the videos we'll have in the coming sections. Now we have a microcontroller, but what do we do with it? How do we use it? What is the identity of a microcontroller? We run applications on it. In the coming future, you will see this secure IoT which we build will be everywhere around you, but you won't even realize it. You won't even realize it in the sense, whenever you're buying a phone, whenever you're buying a laptop, you will see this is a microprocessor, this is the speed and all stuff. But secure IoT is targeted at a segment where it is hidden. Like if you see the applications here, it's smart lock, smart meters, smart watches, thermal printers, drones, and commercial applications like refrigerators, ACs. Many people won't think of what kind of microcontrollers are inside that. The security is targeted in those segments. And in fact, as a proof of concept, we have built some applications. And people might ask, we got the chip few weeks before. We tested the chip few weeks before. We booted it few weeks before. But how did we build the applications on it? That's when the FPGA boards come into play. So FPGA board is a hardware in which we emulate a digital circuit which we design on the computers. So in simple terms, if you say, like how we execute a C++ program or a Python program on software on a microprocessor, similarly, we write a we emulated the secure IoT, the hardware, on an FPGA. This FPGA can just mimic what it will do when we actually manufacture the chip. So we program the FPGA with the secure IoT, with our secure IoT design, and some of our applications are. I'll show you. So one of the application is stepper motor. uh, Stepper motor, people might heard. In simple terms, it's just a motor in which we control the speed, direction, and all. And whenever we go into an application, there are common things which are present are the microprocessor, obviously the brain of the whole system, and the power supply unit to power it, some sensors from which we read some data, and the microprocessor takes decisions on the data and produces an output on the motors, which are the actuators. Then, so this is a video of the stepper motor. If you can see, there is a green board, which is an FPGA board. That FPGA board which is hosting our security microprocessor. And 3 stepper motors are controlled. The speed, the direction are controlled at the same time. So why did we show this application? This is just a simple application as a proof of concept. But what it can lead to is this can go into a lot of other stuff like smart fans, electric vehicles, wherever a CNC machines, 3D printers, wherever a motor is inside it, wherever a motor is used. And then another reference design is a smart lock. It's a slightly complex design than the stepper motor. In this, instead of just having a one control, we have a lot of sensors, a lot of things to control. Similarly, like in the stepper motor, we have the power supply unit, the microprocessor, the brain, the sensors, the actuators, and everything. If you look at the video, so same green board, we have 4 different control. How we can control in 4 different ways via mobile application. And if you see, there's a deadbolt. When the signal is sent, the deadbolt is open, which it indicates that the door is open. So first we showed with the mobile application, next fingerprint, and now with the key card, which detects the NFC ID and then opens the latch, and using the pass key on the keypad. So these are some of the proof of concept we have developed, and these reference designs are available. So if anyone wants to collaborate with us, we are ready to collaborate. Thank you for your attention. Thank you.
Thank you, Mauna. So as he said, these are only 2 of the reference designs. We've done about 5 or 6 already, and we are building many, many, many more. So as time goes on, we are doing our best to collaborate with people and build applications around secure IoT. It's not just this industry is not just build a chip and sell it. This industry is build a chip and work with people to make the chip usable outside. Now to make this chip usable and to build all these fancy applications that we will see, the next important layer is the software. Now to talk about the software, I have one of the most interesting people at MindGrove, the longest running intern at MindGrove and the longest running intern at Rice Lab probably. Kapil, uh, you can say he did his BTech at Rice Lab, though he graduated from Meenakshi College, which is an affiliated college of Anna University. And he has uh, been a pillar of the Shakti project, developing software and developing SDKs, porting things, making things work since before I came into the project. So I invite Kapil to take us on the journey of how we built an SDK, a software development kit, and made the secure IoT chip usable by people in the industry and usable by the people who are building these reference designs like Mauna. By the way, they work together. It's not like one works on applications, one works on the SDK. They all work together. But for the sake of this, obviously one is presenting this and this side and one is presenting the other side. Kapil.
Okay. So hi all. Good evening. So I will just start my journey like this. So I first met Dr. Shankaraman sir through my. I got introduced to him through my Gurujis who encouraged me to visit IITM. So at the age of 17 in the year 2019, I had very little knowledge about IITM, and I was studying at Meenakshi College of Engineering at that time. That was my first year in my college. So yeah, Dr. Shankaraman sir directed me to Professor Kamakoti's office and CS department. So after meeting Dr. Shankaraman sir, he just introduced me to Professor Kamakoti, and they assigned tasks that led me to my involvement in the Shakti project. So I developed bare metal applications for the Swadeshi microprocessor challenge conducted by MIT and IITM. So while working on Shakti's software side, Sharon and Shashwat offered me the internship opportunity at MindGrove Technologies. So initially I was solely focused on contributing to Shakti without much knowledge about MindGrove's activities. However, after learning about MindGrove's vision to globalize Shakti, I was inspired, which led me to where I am today. So there were only 5 of us initially at MindGrove. So Shashwat, Sharan, Uma Maheshwaran, Mauna, and I. Then the team got developed, and we were in the base stage of the Secure IoT's development. And since I had previous experience in the SDK development, I just continued to do the same here in MindGrove also. So now let's go back to the topic. A programmer can choose to write a program without using an operating system. So the first way we call this is a bare metal program. For secure IoT, we provide the software development kit to allow such bare metal development. This software development kit was built using the software development kit created by the Rice Lab for the Shakti project, which was used in the SP 2020 challenge. So we improved on it by making it industrial standard and easier to use. So this bare metal programming is used for smaller or less complex applications. So and the other way of programming onto the chip is using the real-time operating system. Also, this is called as RTOS. So RTOS is a specialized operating system that is designed to manage resources in real-time applications like the CPU, memory, I/O, etc., and task scheduling. So let's assume a car engine control unit uses an RTOS to schedule tasks such as fuel injection, ignition, and the emissions control. These tasks are so crucial that these must be completed within very strict timing constraints in order for the engine to run smoothly and efficiently. So the MindGrove Silicon Secure IoT or the MindGrove supports Zephyr RTOS, Free RTOS, and the Nutex RTOS with the support from the RISE Lab. But Zephyr is our favorite as it is managed by the Linux Foundation, which provides debugging facility very easily. So we also provide users with an ID, which makes the programming very easy. So now let us look at the matrix multiplication application running on the Zephyr RTOS on the Secure IoT chip. It's a 4x4 floating point matrix multiplication. So just focus on the screen so that this video will run so fast that you can't even realize. So that much fast our chip is. Yeah, that's all. It booted. I had to scroll up and scroll down again for you guys to get how much cycles it takes for the computation. Yeah, as you can look at it, it just takes 1387 cycles. So, which is less than 2 microseconds on our chip. So, floating point matrix multiplication running this fast ensures that this chip is so fast. So, okay, here we name the chip Secure IoT. By now, you must have realized that this chip also has secure boot in it. Uh, so, if any application is about to run on the chip immediately after the boot, then the secure boot ensures that the application is not tampered and it is the same code written by the user. So here is the slide showing you the secure boot process outline. The actual boot is so much complex, but we can't put whole thing here because the slides, because that diagram don't fit in the slides. So here, uh, the green color start is letting you know the start of boot, and in the boot, so it will check if there is any application present in the flash memory. So in case if there is no application present in the flash memory, it just goes into the, it just prints no application and then goes into the parking loop. So which makes it easier for us to debug. So if any application is present on the flash, then using Secure IoT's crypto modules, we will perform the integrity checks and we will find whether the application is tampered or not. So if the application is not tampered, then no problem. The code will start executing. The user written code will start executing, or else it will just throw an error, go into an exception, and just go into halt mode. You can't do anything. That just stops working. So this is the level of security we have. Yeah. So having looked at the secure boot's overview, so I will share one of my experience in getting the secure boot work. We put a great effort to get this thing work on FPGA. Huh. But this is not the great part. When I told Sharon that secure boot worked, he just asked me, what's the size of the executable? I just told that it was like about 178 KB or so. Then he just told me, try bringing it below 8 KB because that's our boot ROM size. It was a huge heart attack for me, but still, I wanted to do that. Then I made few changes in the boot code and brought it down to 107 KB, but that's still not enough. And then got down to compilers, read more about compilers and optimizations, etc., and writing a few functions in the RISC-V assembly language itself. And doing all these, it came to 21 KB, from 178 KB to 21 KB. And finally, after removing the prints, you know what? The boot code didn't work on the FPGA. So then found there are really some bugs present in the boot code and fixed them. And finally, we achieved the target by bringing the binary size down to less than 6.5 kb. Yeah, this is my part in designing the chip. And thanks to everyone who helped me in this journey, my parents, Gurujis, professors, etc. Yep. Thank you, sir. Yeah.
So now we've been talking about how we use the chip, and now it's time to go into exactly how we design the chip itself. To talk about that, we have another very interesting MindGrovian. Rohit is, by the way, I forgot to mention that Kapil is also doing his MS at IITM. You'll find that to be a theme among the entire team, apart from me. So Rohit is another great resource, and he's very talented designer. He was the one who got beat up the most in the design cycle. So he's here to talk about how we did it, and also how frustrating it can be at the end.
Good evening, everyone. I'm Rohit Srinivas. How do we change this slide? So now we have all seen how the application is being built for secure IoT, and this was all done on the FPGAs. And I think it is important for us to understand how the actual design is being done. So let's start with the base of the secure IoT, which is the Shakti C-class microprocessor that's based on the RISC-V ISA, and it was developed by the RISE Lab team headed by Professor Kamakoti. It enabled us to bring up a product that can compete on the world stage, and we are extremely grateful for that. Thank you. Also, when we adopted the secure IoT, we also adopted this programming language called BlueSpec System Verilog. This has actually enabled us in part to achieve quicker turnaround times and bring the product out to the tape out quickly. And so we saw all the applications that's being run on this chip. To enable that, we will have peripherals, and these are all collection of communication protocols that is used to communicate with the external devices such as sensors, actuators, and memories. And we believe that security is very important, and anything that goes out of the chip should be secured. So we also provide security complexes, and it has a lot of cryptographic algorithms. And let's all collect all the other foundational and additional IPs into a separate block. Now we have such blocks, and we need something that to connect or to bind all these components together. That's where the interconnect comes into the picture. So essentially what we have done now is envision the secure IoT. Now that we have an idea of what secure IoT is, it is important to bring it to code and then to circuit. So this is where the entire flow is summarized. What we had initially was the idea, then we'll do an implementation. So in past, the circuit designs was done by hand, but those days are gone, and now the designs are very complex, and it's very huge. So languages like BlueSpec, System Verilog, and Verilog are being developed to describe the hardware. Then we come to the synthesis. What synthesis is actually taking the code that we wrote and converting into converting it to the circuit diagram or circuit logic diagram that we know and love. Next is Next is floor plan. Floor plan is very similar to Vastu, where you decide the layout of your house when you're building a new home. It is very similar to that, and the electrical components are very sensitive to their environment, and floor plan is basically getting the blueprint of the entire chip. Next we have is the place and route, where you fix the position of the electrical components and you run copper wires to get the electrical continuity between the different electrical components. And the last one is sign off. Essentially, when we give this design to a fabrication plant, or what we call a foundry, they will give us certain checks and tests that is required to be run on the design. And once these tests pass, they will accept our design. So the final sign off is essentially running these checks and tests. There are a lot more intricacies between these, between the summary that I've given here and this entire thing could be a course on itself. In fact, Professor Kamakoti is also offering a course in computer science department called Care for VLSI, and that has actually helped me to understand the entire flow itself. Once we do the entire flow, we will come to the, we'll get what we call the GDS file. Essentially what GDS file is a text file that when the fabrication machines can understand and print or etch the circuits onto a wafer of silicon. So one of the things that I'd like to mention during the entire process is trying to solve setup violation. So this is one of the nightmares that we faced. This type of violation hinders the performance of the chip, and it is one of the very key factors in determining the frequency of the chips. We always talk about frequency when we say about a microprocessor, and this is actually one of the key factors in determining the frequency of the chip. When I was looking through this, and I found some interesting picture on the internet, credits to VLSI Tales. So this was a very fun picture that describes the setup violation in a single picture. So what essentially setup violation is, the clock that you see, the driver essentially goes in front of the rickshaw. So this is a very peculiar situation, and this should not actually happen, and the driver should be in sync with the auto rickshaw. So why this would happen is, just for sake of understanding this, because of imperfections on the road like speed breakers or potholes, the auto rickshaw can get desynced with the driver, and this is what we get. So this is very, from a designer's perspective, this is also very similar. What the designer's responsibility is to make sure that there are, we will not be able to create a perfect flat out road. So there will be imperfections, but it is the designer's responsibility to keep that imperfection to a minimum, and that will lead to a successful and high performant microprocessor. Thank you.
Thank you, Rohit. So how do we find out that the driver has gone away from the auto rickshaw? And the way we find out is by working on the verification side. For verification, we have the most methodical member of our team. Typically, a verification team in a large company is very, very large. We call it the verification army. Now, we didn't have an army. Well, it's still the largest team in MindGrove, but it's not an army. How we managed with a small team to do the same, to do enough verification that we were confident that our tape out would work, is something that Santosh will walk you through.
Hello everyone, good evening. So I am Santosh Pavan. So let me start with what is verification. So let me start with what is verification. Uh, so basically it validates and ensures whether the implemented design is meeting with the expected specification. So in order to do verification, first we have to build infrastructure which meets our requirements. So let's see what infrastructure we build in MindGrove. So in general, like Shashwat mentioned, organizations have very huge verification army, but as a startup, we had small team. So we developed our own infrastructure according to our requirements without compromising the efficiency and stability. So also we built infrastructure in such a way that test development takes less time. This allowed us to spend more time in debugging. So, but how did we build this infrastructure? So it's Python. So there is an open source Python framework called CocoaDB, which enables us to write test bench in Python. Shakti team is already using this framework for so many years. We adopted this framework, and using this framework, we built our own infrastructure here. Uh, so I think Rohit explained the full RTL to GDS flow. So in order to ensure the full functionality throughout the process, we need to run the simulations or emulations and analyze the results. So yeah, as you can see in the slide, so complexity of the verification process increases as RTL to GDS flow progresses. So debugging at later stage is very painful and difficult. So we developed a test such a way that we can use these tests across all platforms. If there is a problem in later stages, we could go all the way to RTL results and analyze and debug the, we can hunt the bug. Yeah. So let's, okay. So let's see let's see one of the example here. So this is, we capture the same signal through across all the platforms. You can see this is the very first event happens after the chip boots. So yeah, so, yeah. Coming to nightmares. So tape out journey is not a smooth process. We had to deal with so many nightmares. So now I'm going to explain two such nightmares. So let's say T has tape out deadline, and just 45 days before we have to freeze the RTL. Okay, so the the one day, previous day we got an issue where all the RTL tests, all the RTL simulations were passed, but not gate level simulations. So one particular test was failing at that time, and so there is only one day left to debug this issue. At this point, we felt that if we couldn't fix the issue, uh, we might miss the tape out. So we analyzed the simulation results rigorously, and we found a bug. So do you know what is this bug? So it's a integration bug. So there is a connection issue between SOC pins and pads. We couldn't catch this bug at functional level because functional verification could verify the SOC level, not the pad level. So, and we fixed this bug, and we were able to meet the deadline, basically RTL freeze deadline. So, coming to second nightmare. So before diving into this, let me explain what IR drop is. Let's take a water pipeline. If there is enough pressure on one end of the pipe, water can flow to the other end. If there are so many intermediate connections, pressure might drop and water can't flow to the other end. In the same way, if there is a huge voltage drop inside the circuit, then required current may not flow through the other part of the circuit. So this voltage drop is nothing but IR drop, and I represents the current and R represents the resistance here. So just 10 days before the tape out deadline, we observed IR drop issues in the chip. We analyzed the test to test and log to log, and it took us 5 days to find the issue. And how we found the issue? We observed that there is a high switching activity at QSPI peripheral. Then we thought of measuring actual transaction speed in FPGA. We bought a QSPI flash and connected to FPGA, and we ran the application code on it, and we understood that 100 megahertz is too much, and let's decrease the specified frequency to 70 megahertz, and with we modified in SDC, and we did IR drop analysis again, and this issue was fixed just 4 days before the tapeout deadline, and and now we were able to meet the tapeout deadline. Yeah, yeah. Thank you.
So, what Santosh is not telling you, by the way, Santosh is yet another of our MindGrove MS students. He's doing an MS in the W department here. So, what Santosh is not telling you here is the kind of terror that happened 4 days before we actually had to. That T over there is the day that the design goes to fab. If the IR drop issue had existed on the day we went, basically the chip did not have enough power to even boot up. It takes, it was terror until the night, even on the night that it was going into foundry, it was terror. We were up all night without anything to do because, I mean, everything is done at that point. It's just sleepless nights. Now, design has gone to foundry. What next? It has to come back and you have to do something with it. So what do we do with it? And for that, I have the person here who's the only person I trust in the team to take the chip out of the packing it came in. By the way, the packing is there. Can you hold it up? To take it out of that package, put it, well, first of all, to design the board on which the test board onto which the chip goes. To take the chip out of that package, put it on the test board and boot it up. So please welcome Swati, who is our PCB and also physical design engineer at MindGrove.
You, Shash, for introducing me. Technical, right? Thank you, Santosh, for explaining it in simple way. Good evening. I'm Swati, electronic system designer at MindGrove Technology. My journey is a kutti story here, which started from HPCRC lab, IITM to MindGrove. My guide, Dr. Noor Mohammed, my mentor, Dr. Dayala Kumar, introduced me to MindGrove. Sharon and Short brought me into the help with the hardware side. I still remember my first day at MindGrove on office at December 2022. You can see it's a very small, young team of 10 people, including HR, top management, and admin. I'm the one with PCB design experience entering to the office. It was very fun to handle the team and answering all their questions. Apart from them, they are super talented in their own domain. Here comes my contribution of wafer pin planning from the PCB designer perspective, which helped them to write a RTL for secure IoT. Great. Here comes the end of the first half of the movie. Now we will move to the main picture. We knew the application and our target, which gave birth to the secure IoT design. But we need some clothing, right? Which is packaging. This clothing came in a different sizes, different patterns. It's very hard to decide which package we need to go. Because as we are using unconventional way of designing a wide range of applications, wow, the painful task of designing the package was somehow managed by our team. All set, we decided on the packages, dive into the fabrication and went to it came out of the factory and went into the package unit. We thought all the great things were done. God's reply was no. Shashwat will explain it what is its actual later. Meanwhile, I was designing the PCB board, which then was fabricated and assembled. Who forgot to mention RTL team and PD team, they acted as a data sheet for me for the chip. Just think how the collaboration is. A small team, we are easily accessible to each other, help us to think in a different ways. This was a great strength for us, actually. And there is a climax. Board came, chip reached the office, then the dig moment started. The moment I still remember with the full EST protection, all team members were eagerly waiting to see the chip booting message. I was the one who was handling the chip, took the chip outside the EST tray and placed it in the socket. Oh man, you don't know how much my heart was pumping at the time. And to the sweet surprise, the chip was not booted. Very much disappointed in all our faces. Keeping our emotion aside, the engineers inside us pop out of the action and found that it's a power supply issue. We all got a crazy ideas to resolve the problem. Adding to those, it was a holiday with no proper electronic shops open. We took an Arduino board from the shelf we used and just gave the supply to the board. It sounds crazy, right? Board still worked, but power was not an acceptable range. Here comes the Rice Lab and Pravatak. They helped us providing tools and instruments to solve the problem. Some kuti problems are resolved in between. Our team worked around one, yeah. This is the board I was designed actually. You can see that I was holding the socket. And you can see this. You can see the emotion in the video. One fine night. One fine night around 10 o'clock, we saw the beautiful message from the chip. Chip started communicating to us. Felt number J Chutomara. Thank you one and all for patiently listening to my cutie story of success, which actually turned to a long one. Team is our backbone, technology is ours. So everyone feel free to collaborate. Special mention, I would like to thank some great people in my journey. Thanks to my parents, Mr. Srinivasan and Premlata, without whom I am nothing here. Dr. Noor Mohammed, MindGrove team, Shash and Sharan. Thank you to my brother and sister and friends tolerating me. Thank you, Pravatak and Rice Lab, for your great support. Last but not least, it's just a MindGrove's beginning. Thank you. The team is a whole crew you can see here. Thank you.
So, thank you, Swati. What she's not telling you is that the people who were sitting in at 10 o'clock in the night and trying to make the chip boot against my express instructions to go home were Swati, Kapil, all of the team that you see here. They were sitting right into the night. I get a call at 10:30. Shash, chip booted. I said, what? Wait. Step back a few steps and tell me what all you saw. And then they sent me that video. So let me show you, after all of that, we started with the chip booting, we ended with the chip booting. And let me show you the chip. It's very hard to see. And because of just how precious this is, I'm not holding it with my hand. I'm holding it with this vacuum pump. You can see the chip here. This is the first chip MindGrove fabricated. This is chip number 1. So, 1 second, let me just keep him. So, I'll show you again, sir. So, I have to say 2 things over here. This is not a vote of thanks because that is coming, but this is just from MindGrove side, we have to thank a few people who are here and not here. First of all, thanking Rice Lab and Pravatak feels like the left hand trying to thank the rest of the body. We are all part of the same team, and it's just so much gratitude we have for this collaboration. I have to thank the team for, as Swati said, we are all just sitting together and working together. The collaborative environment is just amazing. I have to, one mention that I have to make of a team who helped us, a company which helped us, is IMEC, the Inter-University Microelectronics Center, who served as our contact point to the foundry, to the packaging, to the testing, everything. And Swati mentioned a point where the package did not work. Now the packaging is very important. You can make a die, you can make a chip, but then if you don't get, what is this, Shash? This is just packaging that you guys are talking about. Isn't it just like putting it into a box? No, it is not. If the package is not correct, the chip will not work. And when we found that the package we had chosen did not work, and we made a call to the IMEC team. It was a few minutes. And they said, okay, if not this, we'll shift to that. This is what it's going to take. This is how we're going to do it. And Sharon and I are panicking on the call. The experts from that side are happily holding our hands through this. There are many other situations where they held our hands and helped the team through. I'm very thankful to IMEC for helping facilitate this. So that is one. And finally, I have to thank this whole community of experts from the RISE Lab, from IITM, from Pravartak, from the incubation cell, everybody. Last but not least, I want to thank, at the end of the day, building technology is one thing. Building technology is something that we know. How do you get it out to people? How do you communicate? I want to just mention the CodeVoice team who has been helping us talk to our customers and craft our message and make this not just a one-way selling journey, but a two-way conversation and a story that we are building together with the people who use the chip. So thank you guys. Amrit and Nikhil are here. Hi guys. Thank you very much. Thank you to everybody. And I will hand it back to Rudra to close up the event. Thank you.
Thank you, Shashwat. May I now request Director to give a closing remarks.
So friends, what it means to make a chip, I hope this journey you have just looked into it. Many organizations have hundreds of people to get out with the same class level of chip, that with tens of people, just 10 or 15 group members, I think they have come out with this very successful 700 megahertz at the least speed. They can still increase the speed over a period of time. I'm sure it will be 850 to 900, if not 1 gigahertz if you are lucky. But I think this is what it means to make a chip is this much. And every point, every step, there is a high risk probability. It's like tossing a coin. At any point you get an head, you fail, right? And then the probability of head is also too high. So they have actually worked on least probability at every time to see that every step has been successful. So I must place on record, thanks to MIT for the microprocessor development program, without which this Shakti base which they have used to actually customize to get the secure IoT would not have been possible. IITM Pravartak, the Department of Science and Technology, which actually provided the first pre-seeded funding to MindGrove under the National Mission on Interdisciplinary Cyber Physical Systems. And then Synopsys, the CAD tool vendor, and then AWS, which has actually provided the cloud infrastructure. Though we paid them, of course, they are given it at a good cost to this so that it's affordable to the organization, and many other funding venture capitalists who have funded MindGrove to come to this level. And of course, IIT Madras and the Ministry of Education have been the backbone for doing all these things. I also want to place on record my deep sense of gratitude to Pratap Subramaniam, our distinguished alumnus, being gracious enough to fund us, the Pratap Subramaniam Center for Digital Intelligence and Secure Hardware Architecture, part of the Computer Science Department. And of course, Mahesh and team ACR, our alumni and corporate relationship, for enabling this funding. So this is all, so many people, so many tools, so many things have to come together to make this piece of hardware. This is just a beginning. MindGrove has just begun. There are other companies that are also going to come up. So we'll have such success stories, and I would love to see more and more people participating in the success stories, get inspired about this, and we'd like to see more startups coming up and our startup 100 deal become a reality. Thank you very much for attending today, and I request Richa to come and say a few words, and then we wind up.
Thank you, Professor Kamakoti. It's been a complete pleasure for me sitting there and listening to this wonderful story, this journey that has been undertaken by a very, very young and talented and committed team from MindGrove. So a big round of applause for the team here. It gives me immense pleasure to say that we are very keen on our Startup 100 mission. This is the first Triumph talk, and we want to celebrate such triumphs maybe every month, then every week, and if possible, every day. That is completely and completely out there, and it is achievable. I think the talent pool, the tech, the brain, the commitment, the skills, we have everything. We also have a very, very supportive alumni. So there's nothing that stops us from making this a reality. I just want our student community to get inspired to set up such startups, to work on their ideas. I believe when you are in college, that's the best time to basically tinker on your ideas. If you fail, there is nothing lost. You learned a lot. So with that, I would just put it out there. All the students who are here and who are not here because of their exams going on, those who are here, please take the message. Please talk about this journey of MindGrove. Let it inspire all of you, and let us have many more such success stories coming out of IIT Madras. Thank you all for joining us today. Thank you so much.
Thank you, Professor Richa Agarwal. May I now request Mr. Srinath, our 1993 alum, to deliver an address.
So this is kind of embarrassing because I just came to meet Dean, who I know as PV from Ganga Hostel. So he brought me here. I just heard you guys, and this is like very impressive because I work on these kinds of products, right? Work through the process, through the design, through fabrication, through the qual testing, and we have hundreds of people who do this. So for a small team like this to do it is very impressive, right? And so I currently work at Amazon, and probably you have heard this director about Kuiper. This is the satellite internet that we are planning to launch. And so we have our own internal IC development, testing, all the way through the satellite launch at Amazon, right? And before that, I used to work at Analog Devices, again in technology development. So I have worked in the fab, then I worked on the product side, I worked on the business side, I've dealt with foundries. So maybe the one thing I can kind of tell you guys to keep in mind is there is always a business at the end of it. Don't get carried away with just the technology, right? So you have a product that you need to bring out into the market. You have to make sure that you're testing the product the right way, you're getting the right quality, the right performance at an affordable cost, right? So how are you going to get to that point is what you need to always keep in mind. So very good work. Thanks.
Thank you, sir. That's a very good motivational message from you. Before closing, may I now request Ms. Nandini from Nirman to deliver the word of thanks.
A very good evening to one and all present here. So it has been such an honor to be a part of this wonderful event. On behalf of the Office of Innovation and Entrepreneurship, I would like to extend my heartfelt gratitude to each and every one of you. First and foremost, I would like to convey my thanks to Honorable Governor of Tamil Nadu, Thuru R.N. Ravi Avargal, for gracing this occasion online. I would like to convey my thanks to Honorable Secretary to the Ministry of Education, Government of India. Next, I would like to extend my thanks to our Director, Professor V. Kamakoti, for always encouraging and supporting the innovation and entrepreneurship initiatives around IIT Madras. I would like to thank Professor Richa Agarwal, advisor of eCell, for evangelizing entrepreneurship on campus. I would like to appreciate Mr. Shashwat and Mr. Sharan Srinivasa's team from MindGrove Technologies for being here today and inspiring us. It was fascinating to see the journey of making a chip. Amazing to see everyone's contribution in making this possible. Kudos, guys. Thanks are also due to the student community for being here today in spite of the fact that this week being the middle of the exam week. Thanks, students. Last but not the least, I would like to extend my heartfelt thank to all of my office staff at the Office of Innovation and Entrepreneurship for their unflinching support to make this event a grand success. Thank you so much.
Thank you, Ms. Nandini. May I now request Director to honor all the members of MindGrove. Thank you. Thank you for joining. May I now request everyone to rise up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. We have few refreshments have arranged there. Please help yourselves. Thank you for joining.